Good morning. Welcome to our seminar, Design Automation with Dynamo. My name is Lawrence Hooker and I'm a technical consultant at Symmetry, specializing in our computational design tools, structural products and cross-product workflows. So in this seminar, we're going to focus in on design automation with Dynamo, an increasingly important topic which drives for more efficiency both in time but also in our efficient and sustainable use of our diminishing Earth's resources. Whilst automation can of course improve efficiency, it's all about improving accuracy of the design by taking away the chances of human errors. It's also about understanding our design, refining and optimizing it to improve performance and reducing the impact on our environment. There are hundreds of possibilities with regards to automation areas within Revit. And what I've done here is aim to show you some generic examples which should be useful to all Revit users. Before we take a look at the top 10 scripts, let's spend a short while looking at the benefits of design automation and how you can utilize these powerful tools and workflows. When we look at the transition from 2D CAD to 3D Revit models within our AECO industry, we know that information and communication are the key parts in understanding what we are fabricating, building, and eventually operating. 3D visuals, quantification of materials and elements all help us to create better and more efficient construction and fabrication. But in the future, we will be asked to design and build more, faster, with a better use of Earth's natural resources. That means that we will ultimately need to dedicate more time to the design and planning phase of our projects. This webinar looks at how we can automate many of the tedious and laborious tasks to free us up for those real challenges that we'll face today and in the future. Dynamo can also enable workflows with other design tools to help reuse information generated within Revit. For example, complex facades can be broken down into individual panels, refined and transferred to fabrication and manufacturing software such as Inventor. Mundane tasks such as naming families and renumbering elements can be taken care of in Dynamo, freeing you to concentrate on the actual design. Dynamo can also play a key part in generative design, where design problems can be refined and solved, giving the optimal solutions without having to spend many weeks on other design alternatives. Of course, automation can be enabled by programming dedicated tools within a development environment, compiling the code and then adding these tools to the Revit ribbon. This is a great solution for common workflows that you'll perform numerous times. However, this type of programming really requires the relevant skill sets and time to develop and test these types of solutions. Dynamo empowers the actual designers to create their own automation and design scripts in a much shorter space of time. The great thing about Dynamo is it's based on a visual flowchart, which requires no prior programming skills and is ideal for the designers. This makes it easy for project-specific workflows where an investment in hard-coded solutions may not be that cost-effective. Anyway, now let's take a look at the top 10 scripts. My intention here is not to demonstrate each solution, as this would take much longer than we have. The idea is to show you what's possible. However, I do plan to show the building of one of these scripts live, and in the process I'll also show you Dynamo for Revit 2023 and its new look and feel. Okay, so let's now start to take a look at each of my top 10 scripts. So even in the world of digital engineering, at the moment, most of us are required to produce 2D drawings and documents to document our design and help communicate this to fabricators in the construction site. This script will automate the creation of drawing sheets by creating the sheet names and numbers in Microsoft Excel, and then using Dynamo to generate the actual drawing sheets. This is one of the many tasks that we all have to complete, and this is perfect for automation. Okay, so here you can see we're starting off in Microsoft Excel and we have a simple list of drawings. Excel's great for this task because you can see we can just drag down those numbers here and obviously that's incremented through. We can do the same thing for our sheet names, the unit class code and so on. So obviously we can save off that Excel sheet. And once that's saved off, we can then launch that and run that within Dynamo Player. So here we are in Revit 2023. We've just launched the Dynamo Player. And this has actually had a refresh actually. You can now see that we have nice little icons that we can add into our Dynamo Player. And we can simply just play the script and interact with it. So we've already selected our Excel sheet. We can open it in Excel or just leave that at false and then run. And of course now Dynamo Player is reading off all of those sheets. I can see straight away we have 35 sheets created. Notice that it's been classified by the Uniclass 2015 code. And of course, if I open up some of the sheets that Dynamo's generated, you can see the drawing number has been filled in for us, all of the drawing information on the sheet. Of course, it's also put in the relevant general notes as well. And it's done that for all of those 35 sheets set up within that Excel sheet there. So of course, if you were doing this manually, this would be a fair old bit of time spent to do this. So in this case here, you can see I've now got the relevant concrete notes in for those core drawings. Okay, so whilst the creation of levels does not take an enormous amount of time, the management and editing of levels can be very tedious. For example, we may have a 10-story building and need to change the floor-to-floor height just on a couple of levels, perhaps for the plant equipment. This means editing all the existing levels and ensuring that other levels stay at the same floor-to-floor height. This Dynamo script actually comes in two parts. So the first part is going to show us how to actually just generate those levels, and the second part will show us how we can effectively edit those levels. So again here, we'll begin by starting up our Dynamo Player. You can see now we've got these two specific scripts. Notice I've just searched for the word level, and first we'll generate and create these levels. So again, we've already browsed to our Excel sheet. Notice in the Excel sheet, the actual floor level is calculated based on the floor-to-floor heights. Okay, and we've got the level name and the heights required. Straight away now, you can see that Dynamo Player has then generated all of those levels automatically. Of course, if we look there, we can see that we've got all the relevant floor plans. Now, just to show you what would happen if we tried to edit things with floors created on them already, we'll generate a very simple floor, like so. What we'll then do is we'll copy and paste that to all the levels. So we'll just use copy to clipboard, paste a line to selected levels. We'll select all our levels in that list, and you'll see that Revit will then copy that floor up. Okay, so that's fairly straightforward, but what about now if we want to change the floor-to-floor height? So let's go into the same Excel sheet. In this example, I'm just going to set all the levels there to 3 meters. So again, we can just use our Excel tool there to instance that value down. And then we'll perhaps set some plant room levels at 4 meters. So we'll do level 10 there, and also we'll make level 1, 4 meters. We can save that off. And now we can launch our second Dynamo Player script. So once again in here, we can just perform our little search in the Dynamo Player. This time we're going to use edit levels. Okay, once again, we've got the file path to our Excel sheet. Okay, it's just now launched the Excel sheet. And now we can see that change directly in Revit. Notice now all the levels have changed, but more importantly, those elements are still attached to those levels. So we've not recreated the levels, we've simply moved them or edited them. Okay, so on to number 3, renumber rooms. Now, this really isn't just about renumbering rooms. Renumbering elements can require a number of different strategies depending on what we're trying to achieve. For example, renumbering rooms may be done by drawing a spline through various different rooms and then ordering those rooms in the correct order, getting Dynamo to generate a sequence of numbers and then applying that. Another use case might be requiring that each element has a unique number. So perhaps we've got a lot of different elements within the Revit project, and each one doesn't necessarily have to be in any particular order, but requires a unique reference to that element. So these series of scripts will use different strategies to name and number these elements. So let's take a look at a room numbering strategy here. So the first thing we'll do is we'll go ahead and create some rooms automatically, just using standard Revit. And of course, when we do this, you can see that the room name and room number is obviously very much random. I say it's random, it's actually based on the order that the elements were actually created, but regardless of that, they're not in the correct order. They're not numbered as we require. Notice we've got a model line already created. That's been done as a standard model line and drawn as a spline. And again, we'll start our Dynamo player script. The key thing with this is look how easy it is for users, okay, to utilize Dynamo Player. We don't have to be a Dynamo expert to run these scripts. We can just search for what we're looking for. So we want to renumber rooms. Yep, nice simple user interface here. You can see that we can select the model element, which is our spline. We can set up padding, so that's how many zeros we actually have. So if we've got over 100 rooms, we'll probably want a padding of 3. We can add a prefix in. So in this case, we'll put in level 01 hyphen and then run. And we'll let Dynamo Player then collect all those rooms and number them according to the spline direction. And there we are. We can now see that all of those rooms are now sequentially numbered using the padding that we set up. So padding of 3, and they're all prefixed with LO1. So again, massive time benefit there. If we had to do that manually, that would have been a fair old amount of time. So another use case is the renaming of families. So what typically happens with this is when we create a typical project, we will want to rename the families to reflect perhaps our company identity. So for example, at Symmetry, we might actually put SYM underscore in front of all of the Revit families. That's quite a tedious thing to do because it means you've got to go through all of those families and rename them all manually, which obviously takes a lot of time. The bigger issue comes when you inherit a project from another consultant and you need to rename all of the existing families. Okay, this script will easily add prefixes and suffixes. This script will easily add prefixes and suffixes to the existing families that are present within your particular Revit project. So let's take a look at this one. Okay, so once again, you can see that it begins by launching the Dynamo Player. Okay, we're going to rename the families. Now what you want to be doing here is looking on the left-hand side to the project browser. You can see that we've got a prefix there, SYM underscore, but I'm just going to call this ABC underscore. We're searching for all the families that have a prefix of M underscore, and then we'll run. So take a look on the left-hand side in the project browser, and you should see that all of those M underscore families are automatically renamed with our new prefix. And as I say, without this script, you'd have to have a technician sit there and rename every family manually, which of course isn't particularly efficient, not a great use of people's time. And there we are. You can now see that all of those families that had that search string M underscore have now been successfully renamed for our project. Okay, so this one is slightly different. So we're looking at more of a construction workflow here. Now, one of the things we find is that building structures are becoming more and more complex. So setting out these points on site can become a complex operation, especially when we're dealing with curved elements. So in the example of the image on this slide here, you can see that we have a number of curved slabs and they're actually twisting as the building structure goes up through its height. Of course, setting out points around a curve is quite difficult to do. So this script is going to take those curves, actually divide them up or facet them into a number of sub-components there, and we'll be able to extract out each of those coordinates to a text file or an Excel file that we could then push out to a total station. So of course, the total station will then be able to automate the setting out of those elements and the formwork. So again, let's now take a look at this in action. So you can see our building structure here. Of course, we can use our Dynamo Player again, and this one is slab setting out in this example here. Okay, so a couple of key things to note here. You can see the structure. We've got all of these curved elements as we discussed earlier on. Each one of them is in a different location because the structure is twisting. Notice we've got real coordinates set up on our project, so the eastings and northings there, based on a shared site. So you can see that we've got the project base point set up and the survey point. Okay, so we can put in our file name. This is going to be the Excel sheet that's actually generated here. Okay, so it'll just be PTS underscore for the file name, and then I can put in V1. I've got a facet control tool on there as well, so I'm just setting that for 12, but we could actually increase or decrease the facets in there, and then we can just simply run the tool. Yeah, and then we can just rely on the Dynamo script here to extract all of those coordinates into an Excel file that we can then utilize with that total station for setting out purposes. Okay, so there's all the information in our Excel file. So let's just take a look at this. We can see that we've simply got the easting, the northing, and the level that the slab sits on. So of course, some of the levels will be identical because we've got 12 points per slab. Okay. So let's move on to the next one. Now this one is a DFMA example. This is a design for manufacture and assembly. That's what DFMA stands for. And if we think about how we typically work as an industry, if we, for example, were a fit-out company, we might use Revit to actually fit out a number of commercial apartments or residential apartments with kitchens, bathrooms, offices, whatever that workflow might look like. Now, of course, when we actually place out our Revit families to represent one of these fit-outs, for example, let's imagine it's a kitchen, as you can see here, we do that at a very basic level, but what's got to happen then is someone's got to be able to actually extract all of that information from Revit and then produce manufacturing models of each one. So the manufacturing model would, of course, then drive the CNC tools and the routers to obviously cut out all of the individual components, do all of the drilling of all the parts, and also look at things like finishes that people might have requested. So this particular tool here is going to extract all of that information from Revit and automatically create a whole bunch of iParts in Inventor. Okay. Obviously, again, you can see that Excel is our gel between the two Autodesk products. So let's take a look at this. This example here is a curtain wall panel. You can see that we have a number of square panels in there, but we then have these raking panels on the bottom. This is the same panel in Inventor, and you can see that I've produced a flat pattern of this. So that's the folded model, and you just saw it flattened there. You can see that we have all of our parameters set up in Autodesk Inventor that are similar to the panels in our curtain wall in Revit. Okay, so notice now I've got these named P1X, P1Y, P1Z, and I've got that for each of the 4 points around the panel. So what we'll then do is we'll go ahead and select that curtain wall. Okay, and you can see I'm not using Dynamo Player for this. I'm actually just using full Dynamo here. We'll run that, and you can now see that we've generated an Excel file. This is basically the file that we're going to copy and paste into our iPart table, which is what Inventor uses. So notice here, we can go and edit that iPart table. Okay, we'll open this up. Okay, and that will actually generate the iPart table in Excel. Again, this is core functionality of Autodesk Inventor. I can then paste that information in. So obviously all the formatting is done for me. So that's what Dynamo's generated. Simply save that now, and you'll see that Autodesk Inventor generates every single iPart required for that entire project. Of course, now we can just go and look at some of these at random. So let's open up one of these panels. There it is in its folded state, but of course there we can then go and unfold that as well and look at the flat pattern. And we've got that now for every single panel. So we've gone from early design in Revit to a full manufacturing model with total automation. Okay. And, that's something that is very, very useful. And, people are wanting to actually automate that workflow and make more of this type of workflow going forwards in the construction industry. So, yeah, that's a really good example of DFMA. Okay, so this is a bit of an obvious one for most people, and in fact, when I show you the workflow here, we're actually using one of our Navigate tools to actually generate view filters. Now, we've probably all used view filters in the past, and obviously we can color up these elements in our Revit project to reflect a key that we're trying to demonstrate. So you can see in the example in the bottom left of this screen here, we've got various different lighting units, and we're just coloring up those differently. And you can see we've got a legend telling people what the actual colors mean. Now, there's no provision in Revit to actually do that. So this particular script is going to take those view filters and then actually generate that legend that we can put on a drawing. So once again, let's take a look at this workflow. And like I said, this is actually utilizing our Navigate tools, which I'll talk about a bit later on. So you can see here, in this case, we're actually going to do this on some structural columns. And you can see I've pulled out the name of the columns, and our Navigate tool has now colored up all of those elements based on that criteria. If we now run up our Dynamo player, okay, what we're going to then do is get the override colors in there. So we can actually choose our active view, which is the 3D view. Okay, we'll duplicate a solid black fill pattern and just hit run. And what the Dynamo player tool is now going to do is actually create that legend automatically for us. And of course, then we can just drag and drop the view onto our drawing sheet. So that will be the 3D view showing our columns. And then we can go and find the little legend view that we've generated with Navigate. Simply open that. And once again, drag and drop that onto our sheet. Now you can see there's only 5 examples there, but of course in bigger projects, you know, if you have 30 or 40 legends to generate, that is again massively time consuming. Okay, so for this particular example here, we're going to look at the automation and the creation of parameters. And what I'd like to do in this example is just step you through this live in the software itself. Okay, so here we are inside Dynamo. So I'm just going to close this particular script here, and I'm just going to open up one called Create Parameters. Okay, as this opens up, we're also going to open up a file inside Revit as well, like a sample file that we want to utilize. So I'll just close this one down for a minute. Okay, and I'm just going to open up the sample. So many of you will probably remember this sample file if you've used this before. Okay, so let's just switch back into Revit there. Okay, we'll just let that open up. Okay, once it's open, we'll go into a plan view. Okay, so we'll just nip into this this plan here, and we'll now start up Dynamo. And notice now I'm not running up Dynamo player. I'm actually going to run up Dynamo itself, and then I'll walk you through this script. Okay. So this is a bit of an interesting one. As we go through this script, we'll also be able to take a look at some of the new features within Dynamo itself. So I'm just going to maximize Dynamo there. And if we take a look at the script, you can see if you've seen Dynamo before, you'll notice that this now looks very different. So Autodesk have completely rebranded all of their Dynamo nodes. And you can see we've now gone from that sort of light gray color to this nice sort of dark theme now with all of the nodes. You'll see that the grouping has been refurbished as well. So we have nice group titles, and we also have group descriptions that we can put in here. But something that I really like about this new version of Dynamo here is we can simply wrap up these groups. So you can then see it gives us the inputs and the outputs without having to actually see all of the clutter inside that group. So that's again, very nice new feature. So onto this script itself. So what's actually happening here? Well, basically, what this is going to do is allow us to actually put in information into our Revit model based on the MBS requirements. Now, the MBS requirements will obviously be generating parameters for Uniclass 2015, but also for an IFC delivery and also a Kobe delivery. Now, there's literally hundreds of thousands of parameters that can be used in this particular workflow. And normally you would actually have to generate all of these manually. But what we're doing here is you can see that I can type in the group that I want. So in this case, we can see that we're going to actually work on doors here. And then I can actually specify the actual category that the parameter will be created in. So doors is an obvious answer to that. And then if we come across here, we can see that we can choose our group ID. Now, what I'm going to do is run this, but as I run it, I'm going to actually just freeze off this last node here, okay? So it doesn't actually generate the parameters. The other thing we're doing is another new function of Revit 2023 is the units have changed. So rather than using the traditional units such as length, integer, things like that, we've now got something called spec types, which are actually Forge enabled, Autodesk Forge enabled. And this is really just a tool to allow me to get the various different specs out. So I'm going to run this And you'll probably see a couple of spreadsheets start up as well. Okay, that's perfectly normal. Okay, so this is now reading a very large spreadsheet with all of my shared parameters in. Now, let's just take a look at what's actually happened here. So you can see here, let me just go back to that group. I can actually just use this slider bar to decide what types of parameters I want to generate. So in this case, I'm going to generate the parametric group parameters. Okay, and I'll just hit run again to do that. And let's now just take a look at the data that's now starting to flow out of these nodes. So this is basically reading this from a shared parameter file. So you can now see that it's now going to generate all of the parameters associated with doors, okay? And this is going to give me a full Kobe deliverable with parameters on just these elements themselves. So what we can then do is, last step is I'll just unfreeze that node there and I'll hit run. Okay, and we'll just let Dynamo actually complete that. We'll now go and take a look at that in Revit itself. So if we just jump into this sample project here and we select one of these elements here, we can now see that we actually have all of that information just added in here. So again, really handy. It adds that in very, very quickly. So what it's also done is not only has it created the parameters, but it's obviously set up all of my project parameters as well. So under here, you can see that when I go to my project parameters, and I have all of those project parameters configured and set, and you can see in there they all are. So again, that would take a long, long time to actually do manually. Okay, so I'll just close this down. Okay, and we're now obviously back to our last few in here. So I do plan to show you building a script from first principles, but before we do that, I'd just like to take you through the last couple that we need to look at. Now with this one, there's no particular workflow or demonstration, but what I want to really do is talk about the importance of this script. So what this is actually doing is giving us the capability of auditing and checking Revit models. Now, if I asked you to put a monetary value on one of your Revit projects, let's say that you've been working on this project for the last year and you have 5 or 6 technicians working on that, it's probably hundreds of thousands of pounds worth of model, okay? And then you might ask yourself, well, how many times do I actually check that model? You know, is it in good health? We don't know. So the idea with this is we're actually using Dynamo to actually generate and produce reports. Now, the 3 bits of software that we're using here is Revit, Dynamo, and in this case, you can see that we've got a choice of storing the data in an Excel file or a SQL Server database. Now, my preference here is to actually store this in SQLite database and then use Power BI to produce the report. Now, the great thing with this is we can actually store history. So for example, if you're working on a long-term project, you can actually run this audit weekly, then actually see the statistical changes around that project. So for example, how's the file size coming along? How many sheets have we got in the project? How many different Revit categories have we got? You know, how many in-place families are being generated and so on. So this script could have hundreds of different variations, but it's definitely something that's worth looking at there. And the final one is an array along path. Now what this does is this allows you to just simply draw a model line or a model curve inside Revit. You can then take a family and distribute that along a path. Okay, so nice and simple tool, but again can be really, really useful. So that's really my top 10, but of course there could be hundreds of other examples. But what I want to do is just really show you how we approach one of these scripts from first principles. How would we actually start to build this from scratch? So let's just take a look at that now. So I'm going to close down this particular project. Okay, and I'm just going to go into one here called Renumbering Strategies. Okay, this is a really simple project. You can see that we've just got some furniture elements in here, and each one of these furniture elements has a tag. Okay, none of these tags are sequentially placed, so you can obviously see now there's no particular numbering strategy employed there. So what I'm going to do is I'm going to build up a Dynamo script here to generate a numbering strategy. Okay, and you'll see some of the logic that I use to actually build this script. So let's begin by launching Dynamo. And of course, when we do this, you'll see some of the new interface being showcased here as well. Okay, so here we are in Dynamo. I'll just maximize that for the minute. Okay, and we'll create a new graph. So another thing you'll notice is that the node library has had a bit of a revamp. So you can see here, everything looks slightly different. So I'm going to go into our Revit library in here, and we want to start by making a selection. Now, what I want to start with is being able to select all elements of a category. So we'll bring out that node there, and the category we're interested in here is of course going to be furniture. So let's go and pull that out. We'll make a selection set in here. So we want to obviously go and find furniture, like so. Okay, and I'll wire those two nodes together. I'm in auto run, so you can see that this is executing on the fly. And I've got now 107 elements that have been fished out of that selection set. Okay, what I want to now do is get the location of each of those families. So I'm going to go into the elements shelf in here. We'll go directly to elements over here. And you'll notice in here, we've got a node here called get location. So we can feed in those elements, and you'll probably see some graphics now appear in the background of Dynamo. Let's take a look at that. So we'll just zoom out. And what they are is that's the actual insertion point of each piece of furniture. So if we go back and just take a sneak look at Revit now, you'll notice now we've got all those blue dots over those furniture elements, and that's actually the locations of each of those. Okay, so that's what Dynamo's now done so far. The next thing I want to do is I want to actually build a surface basically on all of these. So my intention here is to use the UV locations of each of these points to build up some sort of a numbering strategy. So I can tell Dynamo to perhaps number these from the bottom left or the top right, you know, however it is that I want to do that. So I now need to actually collect all of those points and actually build something from them. Now that something really should be something like a bounding box. So if I go under geometry here, a bounding box is a bit like a coordinate system or a work plane or a vector. It's an abstract piece of geometry. So let's open up a bounding box in here. And we're going to now generate an axis aligned bounding box from all of that geometry. So let's feed that in. And you can see now we have our bounding box that's been generated. What we want to do is then generate a graphic from that. So we're going to create a cuboid from it. Now, in fact, there's no Z elevation on the bounding box. So essentially, it's just a surface anyway. And now we can actually see now in Dynamo, we have that surface which matches the footprint of our furniture, which is the bounding box of all of those points. What I want to do now is go ahead and explode that. So we'll go into Modify down through here, and we'll use Explode, and we'll just wire that in there. Okay, and now you can see we've got the output, which is the surface. Now, before I go too much further, when you start building out these scripts, you really need to start thinking about being able to read the scripts at a later point. So I'm going to now use our new grouping tools to actually create groups here. So we'll give this a title as well. So this will be collect all furniture. Yep, that's what that function of the group is actually doing. The rest of it over here is actually getting the geometry. So we can create a new group on that. I'm going to change the group color here. Okay. And in here we can say create points and bounding surface. Okay. So that's the function of that particular group there. Right, so the next bit is I actually want to now understand the location of each of these points in relation to the surface. And this might be something you haven't really kind of thought about before. So I'm just going to go for a bit of theory behind this first. I'm going to try and use some very primitive drawing techniques here. So bear with me. So that point is roughly the center of our surface. So the U and V coordinate there would be written as 0.5. Okay, so 0.5 in the U and 0.5 in the V. Okay. The start of the surface down here somewhere, obviously it's behind my Dynamo script, would be 0, 0, okay, both for the U and the V. And the top right hand corner of my script up here, my surface, would be 1, 1. And that's how the points are organized around that surface. So for example, if I took a point over here, this one here, for example, that I've just ringed, that would have a U coordinate and a V coordinate that would lie somewhere between 0 and 1. And using that logic, I can actually organize all of those points into any order that I desire. So let's now take a look at how we would do that. So again, under the same geometry shelf, I'll expand surfaces, and we'll now look at surface itself in here. Okay. What we want to do is we want to actually now understand the point and the UV coordinate at those points. Okay, so let's just take a look at if we can actually find that node. As I say, they've organized all these a little bit differently now, and there it is, UV parameter at point. You can see here that first input it needs is the actual surface itself, and then the points that have just been generated. So the points are the element locations. Now, this will enable me to show you another neat little feature of Dynamo, actually. If I just wire that into there, okay, obviously now you can see it's got 1 point. I need to set the lacing, so I'll just set that to longest. Okay, and you can now see I've got all the locations, like I've said, from 0 to 1 for each of those UV location points. But notice this wire that actually goes from get location to the UV is a bit mucky, to be honest. Don't really like that. So what we can do in Dynamo now is we can actually put a pin on that, and I can actually then direct that exactly where I want it. So I could put another pin out over here somewhere. Oop, let's do that again. There we go. Oh, come on. Right, there we go. Got it. Right, there we go. And I can then pin that round. So of course, this stops you having to actually have wires crossing over other wires. Keeps things neat and tidy. Okay, so onto our list here now. What we want to do is we want to now organize these or sort them by the U and V values. So I'm just going to use the searching function now in Dynamo. And what I want to do is be able to actually put out the U values. Now, before I use this in a search, let's just see what it does. And you can see now that's just pulled out the U component of that coordinate in there. Okay, what we want to do is actually sort by a function, actually. So we'll do that. We'll sort by function. Okay, so that's my function that I want to actually sort by the U value, and then we'll put those UV coordinates in. So what's now happened is if we take a look down through the list here, we can probably start to see that all those U values are in order, numerical order, right? But the V values aren't. So we'll do a very similar thing here. We'll get the .v component in there. Okay. And we also want to, again, sort by function. So let's do that. Okay, so that's the function built. Just out of interest, just so you know this, when you're using functions, you put in the function you want to use in here, but you don't connect it to any wires, okay? And that then generates a function. So if I now take that sorted list in here, you can now see that we actually have our U and V values sequentially sorted. What I now need to do is actually work out the index of each of those, okay? So I'm going to ask Dynamo to actually find the index of each one. And by doing this, I can actually take that list in there, that sorted list in there. And then what I want to do is actually find the index of the original points, which are over here. What it would do is give me all of those indices. Now, this is the order of those points, how they should be, okay? Now, we can use a little trick here because basically I don't really care about those points in reality. I care about this furniture up here. They're the things I care about. So what I can now do here is actually get item at index. Okay. So that enables me to take those indexes in there, which are just integers, and then we'll take the actual families across here. And now get item at index has now got those pieces of furniture in the exact order based on this UV arrangement. So now I'm going to ask Dynamo to create some sort of a numbering strategy, and then we'll actually number up those elements. So first, we'll ask it to count how many pieces of equipment we've got. Okay, and there we are. I can see I've got 107. Obviously, that would dynamically update if required. We'll then use a code block. So what I'm going to do in here is generate this numbering strategy. So 1, 2, the count. C is just a parameter. You can actually create whatever you want in there. Let's just show you that by typing in my name, just so you know it's nothing special in there. So that's going to be the variable that I store the count value in. And then what I'd like to do is add that to a string, like so. Okay. Now, once that's organized, we'll put in that line of code in there, and I've forgotten the quotation at the end there. That's why that's gone red. There we are. And then it's asking me for that input, which now is called Lawrence. Obviously, that would have been called C. And I can feed that in. And you can now see that we've generated a nice numbering strategy in there. Okay. And I didn't want those 2s in there, so I'll just get rid of that. And there we are. There's my numbering strategy. Okay. Right. So the final part of the puzzle is to actually set a parameter. So I'm just doing a search here for set parameter by name. And just to show you what we're setting that on, if we select one of these pieces of furniture at random in Revit, okay, you can see here that we have a mark. That's what we're going to write that information back into. And of course, the tag is simply just reading that mark. Okay, so that's the strategy that we're going to use there. So that's the values that I'm feeding in. So that's the list of numbers that I've just generated. The parameter that we're writing into, we said was mark. So I can enter that as a string, like so. Whoops, I've got the caps lock on. Let's just get rid of that. Okay, so that can now go in there. And the elements that we're renumbering, of course, are the actual pieces of furniture, which are over here. Okay, so we'll feed that in there. Okay, we can see we get a slight delay there while Dynamo does its magic. And now if we take a look at the numbering system, we can now see they're all very neatly in order. Now, just to show you some bits and pieces here, if I get that piece of furniture in there and actually shift it round, and then we might sort of get that one over there and place that in a different location, that would actually cause Dynamo to obviously reevaluate all of those positions and renumber them accordingly. So, you've just seen there how to build up a relatively simple script from first principles. Okay, so we'll just snap back to our presentation. Okay, bear with me while I just restart the PowerPoint. There we are. Okay, so whilst Dynamo can automate daily tasks, it's really aimed at project-specific workflows where we can design custom applications for very specific tasks. Our Navigate portfolio of tools for Revit contains hundreds of tools neatly packaged into industry tool sets to automate almost every task you can imagine. Navigate provides dedicated tools that can work together to provide a workflow-orientated solution for a number of different Revit tasks for contractors, architects, structural engineers, or building service designers. If you're interested in our Navigate for Revit range, please reach out to us and we can book you a technology preview where you can actually sample the power of Navigate for yourself.